Okay, so for today, tulad ng sabi ko, we are going exogenic hazard, and the first hazard that we are going to discuss is what we call as astronomical hazard. So pag sinabi nating exogenic hazards, ito yung mga hazards due to external forces. Again, when we are speaking class of exogenous hazards, we are speaking here of hazards, no, which is due to external forces. So yeah. Now, when we are speaking of exogenous hazards, we are speaking of hazards due to external forces. So, example nito yung ay astronomical hazard, and astronomical hazard is an example of exogenous hazard kasi it's due to the fact that these astronomical hazard are caused by materials coming from outside of the planet Earth, no? Galing sa ating galing sa ating external what do we call this, external environment from the earth, no, which is for which is our, what do we call this, ano bang tamang term, ano bang tamang technical term, kasi if you are going to use non-technical term, we can say na yung mga astronomical hazards are due to materials coming from the outside of the planet Earth, or ito yung mga hazards due to the celestial bodies entering planet Earth. No, so if we will use non-technical terms, so I cannot think of any technical terms, pero it's quite stating the obvious, no? When we are speaking of astronomical hazards, ito nga yung mga hazards that is brought by materials coming from outside of the planet Earth, no? Planet Earth. So, no, we will expect here mga impacts, no? Mga impacts and collisions ng mga materials or celestial materials coming from the outside of the planet Earth. So those are examples of astronomical hazard. And tulad ng sabi ko, since astronomical hazard, it's due to the materials coming from the outside of the planet Earth, no, that can enter through the Earth system. We can say that this is an example of a exogenous. This is an example of an exogenous hazard kasi class, it's due to an external forces, no? Hindi siya cause ng internal forces ng planet Earth. So technically, we are speaking of exogenous hazards. Ito yung mga hazards due to the external forces acting on planet Earth. And nga, one example of it would be astronomical hazards, which are hazards materials coming into the earth, coming from our outer space. Yun yung tamang technical term. I cannot think kanina of any technical terms to use. So, coming from the outer space, no? So, that is why itong astronomical hazard natin is an example of an exogenous hazard. Now, aside from astronomical hazard, meron pa ba, sir, example hazards? Yes, napakarami pa. No, yung mga natin has due to exogenic processes. So example natin coastal erosion, ground subsidence, 'di ba? Yung coastal erosion, ground subsidence, no? These are also hazards that is not due to the internal forces of the planet Earth. Kasi 'di ba yung earthquake and volcanic eruption, if you are going to delve to it, no, ang cause ng earthquake at ng volcanic eruption natin are forces coming from the insides of the Earth. It's due to endogenic processes or yung mga forces natin na nanggagaling sa loob ng planet Earth. But if you are going to look at this example, yung tinype ko dyan sa chat box tulad ng coastal erosion and ground subsidence, itong mga hazard na to, hindi siya due sa mga internal forces coming from the planet Earth. Instead, it's due to exogenic processes or mga external forces natin, such as the agent of erosion and the agents of weathering. No, itong mga agents na to are external forces. It's not coming from the insides of the Earth, but it's due to some kind of external forces. No, at itong mga external forces na to, it can cause hazards, na tulad ng coastal erosion and ground subsidence. So meaning coastal erosion and ground subsidence are hazards due to external forces. And we can say if that is the case, this is an example of an exogenous hazard. Yes, David.
Bale po yung katulad po ng wildfire, kan po ba yun?
Katulad ng
Fire?
wildfire, exogenous hazard din yan. Okay, bakit? Kasi hindi naman nanggaling sa internal na or ng internal forces ng Earth yung dahilan nung hazard natin. It's due to an external force. And wildfire is an example of an exogenous kasi hindi naman internal forces ng Earth ang actually due to some kind of external forces. And example nun would be wildfire, which is due to the chemicals no present in the biosphere, no? Yung mga forest natin, ano, specifically, these are not tropical forests, no? Mga coniferous forest to and deciduous forest. And some of the plants there in deciduous and coniferous forest, meron silang mga pyrochemicals that can actually start fire. And if that is the case, hindi siya due from internal forces coming from the planet Earth. It's due to some external forces kaya tayo nagkaka-wildfire. Ganun din yung anthropogenic fire. So that is actually a good example. And we are going to discuss fires, no, including and anthropogenic fires next week. Kasi ngayon ang focus natin is astronomical hazard. But next week, we are going to discuss other exogenic hazard. And that includes your anthropogenic and wildfires natin. And these are example of exogenic hazards kasi it's not due to internal forces of the Earth or it's not due to plate tectonics. Instead, it's due to some external forces acting on the surface of planet Earth. So technically, if the hazard is due to some external forces no, that is acting on Earth's surface, this is considered as an exogenous hazard. Okay. So no, what are example of exogenous hazards? No? So yun na una, yung discuss natin ngayon, we have the astronomical hazards, no? Tawag astronomical hazards, and example ng astronomical hazards is what we call as the bolide impact, no? Tawag natin bolide impact. Yung another example be the coastal erosion and ground subsidence. It's due to some exogenous forces, no? And yun nga, tulad ng sabi ni David, another example would be wildfire and anthropogenic fires. This wildfire and anthropogenic fire are other example of exogenous hazard. So, are you able to get what is an exogenous hazard? Nakuha class? Naintindihan? Grade 12, did you understand what is an exogenous hazard?
Yes po.
Okay, now, so since we're going to discuss exogenous hazard, the first exogenous hazard that we are going to look at is your astronomical hazard. And usually, ano bang cause ng astronomical hazard? Bakit ba tayo nagka-astronomical hazard? So tatandaan ninyo, our astronomical hazard no, is due to the fact na merong mga meteoroids, no? Merong meteoroids in space, no? Ulitin ko, we are going to deal with astronomical hazards. And primarily, bakit tayo merong astronomical hazard or bakit meron tayong no, that is considered as astronomical is due to the fact that there are always meteoroids in the outer space. So, sir, ano ba itong meteoroids na to? And why are they imposing danger or hazard to our planet? So, pag sinabi natin meteoroid, these are actually space debris, no? Mga space garbage sila. They are actually chunk of materials that came out of their orbit. So, usually kasi, most of the materials in our outer space are in orbit around another celestial body. For example, our planet, no, planet Earth is orbiting around the sun. So we can say na yung mga materials, supposedly, the materials in our outer space must be orbit around another celestial body. No? Tulad ng moon, it's orbiting around the planet Earth. But sometimes, nai-strip off, may mga nai-strip off tayong material. And itong mga material na nai-strip off, they are losing their orbit. No? So they become, they become dispersed across our outer space. At ang tawag natin sa mga space debris na to, no, that is removed from their orbit, we call them as your meteoroid. At ang mga meteoroid na to, since they are out of their orbit, they can be encapsulated to the gravity, no, to the gravity of another celestial body. And if that would be the case, no, kung yun yung case natin, pwede yun mag-impose ng astronomical hazard sa isang planet, let's say, or sa isang celestial object. And in our planet Earth, since meron tayong gravity, we can influence other materials in our outer space. Pwede natin ma-capture, no? We can capture this meteoroid into our planet. And by capturing the meteoroid into our planet, no, this can actually cause what we call as astronomical hazard. No, yun nga lang kasi what is alarming about this astronomical hazard. This astronomical hazard can cause great damage on the exposure, no, in a certain geographic area. And usually hindi lang geographic area, global yung effect ng astronomical hazard. And that is why, as much as possible, we avoid astronomical hazard. Astronomical hazard is actually a very rare phenomenon, pero I'm not saying that it is not possible. It's always possible in planet Earth. Kasi nga, lagi tayong may meteoroids, no? There is always meteoroids on outer space. There is always materials on the outer space that is not on an orbit. And this can be captured by the planet Earth at any time. So at any time, itong na-capture natin can cause significant damage, no? Can cause significant risk, no? Globally. Kaya medyo alarming siya. Although very infrequent yung event, but it is a very alarming event due to the fact na it can cause a great deal of damage to the exposure, no? And it can even alter the weather system and the climate system of the planet. Tulad nangyari nung time ng dinosaurs, no? The reason why they go extinct is due to the fact na meron tayong impact during the time of the dinosaur that caused the change in the weather climate system of the planet Earth. So technically, yun yung mga meteoroids natin. They are space debris that is out of orbit. Now, class, tulad ng sabi ko, no, itong mga meteoroids na to, they can be captured, no, by the gravity of the different celestial bodies. And since planet Earth has its own gravity, it can influence, no, by its gravity. So, pwede nating ma-capture yung mga meteoroids na to. And once na-capture natin yung meteoroids by our gravity and nag-enter sila ng planet Earth, no, itong meteoroids na to, it becomes what we call class as meteors. Magiging meteor siya. So, once the gravity capture the meteoroid, no, and it enters the planet Earth, itong meteoroid na to, it becomes what we call as meteor. Now, commonly to all of us, to meteor na to, tinatawag natin siyang shooting star. It's because of its appearance as it enters the planet Earth. Nangyayari kasi, pag yung mga meteoroids natin, nag-enter sa planet Earth, it experience amount of friction upon entering the Earth's atmosphere. So, meteoroid ninyo, pag nag-impact siya, no, nag-impact siya sa atmosphere natin or pumasok siya sa atmosphere natin, it experiences a great amount of friction. No? It's due to the fact that these meteoroids are traveling at a great speed, especially when pulled by the gravity of the planet Earth. So usually, umaabot siya ng 22,000 to 64,000 miles per hour, yung speed ng meteoroid natin once it enters the Earth's atmosphere. And because of that, it experiences a great amount of friction. Alam ninyo, sa laws of physics natin, pag tumataas ang speed ng isang object, tumataas drag or yung air friction or yung fluid friction na tinatawag natin. And with great fluid friction, aabot tayo ng ng increase in temperature up to 2,000 degrees Celsius. And if that would be the case, the meteoroid would start to melt, no? And this melting of meteoroid radiates light, and that is why pag nakikita natin sa sky, we see the falling meteoroid, or tinatawag natin meteors, no, as something that emits light in the form of shooting star. That is why shooting star yung nakikita natin pag may bumabagsak the meteoroid from the outer space. It's due to the fact, no, that it's started to melt due to high frictional forces, and this melting, no, due to this melting that in high temperature radiates light that makes us see eye with falling meteoroids as a shooting star. So that is why we see shooting star. 'Di ba may mga times din na sobrang dami ng bumabagsak na meteor, no? There are too many meteors, tinatawag yun ng meteor shower. And usually, yung meteor shower na to, ibig sabihin yan, may dumaan, no, na comets. Sa possibility na meron tayong dumaan na comets at that point, no? Or if not a comet, no, dumaan tayo sa orbit, sa Apollo orbit na tinatawag. And pag sinabi yung Apollo orbit, ito yung orbit kung saan nag-orbit yung mga yung mga asteroids, yung mga near-Earth asteroid. And to, ang asteroids na nasa Apollo orbit, asteroids class that passes through the planet's Earth orbit. So para may tinay yung sinasabi ko, no, let me show you the Apollo orbit na tinatawag natin. This one is part about surviving for a while, lipat ako ng screen, no? So yan. So itong papakita ko sa screen is yung tinatawag nating Apollo orbit. So pag sinabi natin Apollo orbit, ito yung orbit ng mga asteroids, no, that coincides with planet Earth. Kasi may tatlo tayong orbit for meron tayong tatlong orbit for asteroids. So yung tatlong orbit, these are the following. Meron tayong tinatawag, we have what Apollo orbit, no? Meron din tayong tinatawag na Trojan at meron din tayong tatawag na asteroid belt, no? The asteroid belt, no? Sorry for the spelling, belt yung type for asteroid belt. Yan, no? Okay, yan yung tatlong orbit ng asteroids natin. Now, sa tatlong orbit na yan, ang dinadaanan ng planet Earth is the Apollo orbit. That is why itong Apollo orbit na to, no? Sa Apollo, this is the concern of the astronomers. Ito yung inaaral talaga ng astronomers natin kasi sa Apollo orbit, dito dumadaan yung planet Earth. And since dito dumadaan yung planet Earth, there is a chance, no, we will encounter what we call class as near-Earth asteroids o yung tinatawag nating NEA. There is a chance NEA here or a near-Earth asteroid, no, sa orbit na yan. So technically, yung nasa screen ninyo, that shows the orbit of the planet Earth and the Apollo orbit. So if you are going to look, ito yung orbit ng planet Earth in this diagram, and this is the orbit na tinatawag natin Apollo orbit. And tulad ng sabi ko, Apollo orbit na to, this is a concern for astronomers kasi ito yung orbit na nagko-cross sa orbit ng Earth. So minsan, pag dumadaan tayo across this Apollo orbit, no, nakaka-experience tayo ng meteor shower kasi at this point, napakaraming space debris dyan na pwedeng ma-lift off ng isang asteroid. Kasi these asteroids are always in constant collision together. And remember, sa asteroid orbit natin, napakaraming asteroid ang nagre-revolve dyan. It's not only one asteroid, but several asteroids revolving around this Apollo asteroid. Anyways, asteroid, there are other asteroid orbit tulad ng Trojan orbit na nakikita sa orbit ng Jupiter. At yung asteroid natin, which is an orbit between Mars and Jupiter. So those are the different orbit for asteroid. Pero for planet Earth, specifically if we wanted to monitor hazard, the most important the most important orbit that we need to examine would be the Apollo orbit na tinatawag natin. Kasi andyan yung mga near-Earth asteroid. No? And kasi ang near-Earth asteroid, ito yung mga asteroid na nasa Apollo orbit na possible na magka-impact with the planet upon actions in gravity. So, pwede tayong magkaroon ng impact dyan sa mga near-Earth asteroid na yan na present sa Apollo. So, anyways, let me go back to my presentation. Okay, did you understand that grade 12? Naintindihan?
Yes po. Balikan
May,
accept asteroids na lang calculating ng mga phases na natin.
again, David, what's your question?
Tama po ba ako? Yung sa Apollo lang po sila tinitingnan asteroids.
Oo, yan yung, di naman yan lang, pero yan yung talaga ina-examine nila kasi dyan talaga tayo nag-cross. So, dyan talaga may probability na magkaroon ng impact with the planet.
Okay.
So anyways, tulad nga ng sabi ko, no, yung meteor showers, it can be of two causes. Pwedeng it's due to the comet, no? Pwede tayong magkaroon ng meteor showers due to the comet kasi yung comet natin, it usually left or leave siguro yung tamang it usually it usually leaves several space debris pag nag-pass through siya sa orbit ng planet Earth. And another source of meteor shower natin is pag nag-pass ng planet Earth dun sa Apollo orbit na tinatawag natin, where yung mga near-Earth asteroids are revolving through. So now, pag pumasok na sa planet Earth yung meteoroid natin at nasa ng planet Earth, well, tinatawag na natin siya meteorite, no? So we are already calling it as meteorite. And tatandaan ninyo, for astronomers, no, meron tayong tatawag na false and finds, no? What we call class as false and finds. Ano bang pagkakaiba ng false and find? Kunyari may nakita tayong shooting star. And let us say malaking event yung shooting star na yun. So kung malaking event yung shooting star, ang possibility, pwede nating sundan yung path ng meteor shower tuloy. Pwede natin sundan yung path ng meteor to locate the meteorite. So pag na-locate yung meteorite by following the meteor shower, ang tawag sa material na na-locate nyo is a falls. No? Tawag sa kanya is falls. Fall or falls, pag marami falls. Ngayon, may mga may mga meteorite na hindi nyo na-discover upon collision. May mga meteorite na na-discover nyo after hundreds of years, after millions of years, especially no, in Antarctica. No? Marami tayong nakikita sa Antarctica ng mga meteorite that have fallen in the planet Earth 4,000 or million years ago. No? Ang tawag naman sa kanila is finds. No. So if you are an astronomer and you are in the field of research of asteroids, no, you must familiarize with this terminologies, yung mga falls natin and finds natin. So technically, pag falls, no, trinak mo yung trinak mo yung meteor to locate the meteorite, no, that is associated with the meteor. And do not worry, may activity tayo that would help you understand paano ba linolocate ng astronomers natin and yung mga backyard astronomer. May mga tatawag kasi backyard astronomer, no? Sila yung astronomy, they don't have technical education on astronomy, pero they are usually discoverers, no, and they love to make discoveries for the field of astronomy, mga backyard astronomers sa kanila. Yung mga techniques silang ginagamit, no, to locate the meteorite from a fall or to locate the meteorite as a fall rather, no? And if that would be the case, tatawagin nyo yung meteorite na yan as a fall. And do not worry, we have an activity in our module, so that is module number 8, no, regarding on how to locate the meteorite coming from a meteor. So, paano mag-locate ng fall coming from a meteor? We have an activity there. We have an enriched activity there in the module. So, anyways, going back, no, so yun nga, tulad ng sabi ko, to meteorite, no, Once na natagpuan, it can be in the form of a fall or it can be in the form of a fan. Sorry, fall or fines. No? So, ano ba tong meteorite na to? So, meteorite are actually your remnant. Ito yung mga remnant nung inyong meteoroids na umabot sa surface ng planet Earth. Usually, meteorites are small. Kadalasan small sila kasi na-vaporize. It's expected na they are already vaporized upon passing atmosphere. So pag pumasok sila sa Earth's atmosphere, it's expected that they have vaporized already. So usually, pag umabot sila sa surface ng Earth in the meteorite, usually they are small and grain size. May mga sobrang maliit nga tayo na meteorite na pwede lang makita under the microscope. Tinatawag natin siyang micro meteorites, no? We call them as micrometeorites. So pwede kayong magwalis-walis sa mga bubong ninyo and look under the microscope if you see some kind of metallic metallic rocks, no, or metallic balls under the microscope, probably or possible na these are example of meteorites, no. So, usually, mga ganong mga samples, sinesend yun sa mga governing agents ng astronomy to examine whether that micrometeorite talaga is a meteorite or accidentally kamukha lang siya ng meteorite. So, you can do that actually. Kwento ko lang, no, we have our student years before, no, I forgot anong year, they have their IP investigative project, no, where they collected micrometeorites. So kinumpit nila yung density ng micrometeorites mabagsak sa planet Earth and kinorelate nila yun sa meteor shower sightings, no, here in the Philippines. So I forgot the result of the study pero yun yung study nila. So anyways, pag nagko-collect tayo ng meteorite, no, there are three kinds of meteorites that we actually, itong types of meteorite na to would also depend on ano yung ano yung type of material where they are formed, whether it's undifferentiated or differentiated. So there are three types. We have what we call class as stony meteorite, meron din tayong tatawag na iron meteorite, at meron din tayong class sa tawag na stony iron meteorite. So what are the differences between the three? So unahin natin stony meteorite. So pag stony meteorite, obviously, comprise only of rocks, no? Again, pag stony meteorite, comprise lang siya ng rock. So, it can be what we call as chondrite and achondrite. Pwede siya tatawag natin chondrites or achondrites. Now, another thing that you need to consider for a stony meteorite, most of the time, carbonaceous siya. No? Most of the time, itong mga stony meteorite natin are carbonaceous meteorite. No? So, it's rich in carbon compounds kadalasan. So now, meron siyang dalawang klase. It can be in the form of chondrites or it can be in the form of achondrites. So anong pagkakalawa? When we're speaking class of chondrites, ito yung mga stony meteorites na merong mga chondrules na tatawag. So itong mga grains na to, mineral grains to actually. Itong mga mineral grains na yan, tinatawag yan na chondrules. So kaya sila tatawag na chondrites, they are called as chondrites because they are stony meteorites na merong chondrules, merong visible mineral grains. Kitang-kita natin yung mineral grains doon sa stony meteorite natin. Now, on the other hand, yung mga achondrite natin, sila yung mga stony meteorite na hindi na visible yung mga mineral grains o hindi na visible yung tatawag natin chondrules. Now, the question is, bakit yung chondrites, kitang-kita yung mga chondrules, sa achondrites, we cannot see the chondrules? Okay, the reason for it is that magkaiba kasi yung source of material nila. Pag chondrites class, kaya siya mayaman sa chondrules or mineral grains is due to the fact na undifferentiated pa yung source ng meteoroid. No? Pag chondrite, undifferentiated pa yung source nung ating meteoroid, samantalang sa achondrites, no, differentiated na yung source ng meteoroid. So let us recall your grade 11 Earth Science. Di ba remember, in your grade 11 Earth Science, diniscuss natin yung planetesimals. And pag sinabi yung planetesimals, these are asteroids that forms your planet. So paano ba nagpo-form yung planet? How do our planet form? Sige nga. They must what? You can recall, ano nangyari sa planetesimals when we are forming planet? Di ba yung planetesimals, they collide with each other? No, they are trying to collide, di ba?
So, dito, parang yung dust, yung kanang dust is parang nag-collide with each other due to the gravity.
Oo, nagko-collide sila with each other at a very high speed to form your planet. Ngayon, pag nagko-collide kasi sila, yung mga asteroid natin, pwede yung mag-trigger ng events kung saan madi-differentiate, no? Tulad ng nangyari sa planet Earth, no? Nung nag-collide yung mga asteroids that form the planet Earth, it triggers an event that causes differentiation. So nangyari ng differentiation, yung iron that is present on the early Earth, lumubog siya sa gitna. So pag sa differentiation, no, nasa-sort out yung material doon sa asteroid natin or doon sa planet natin. And just like what happened in planet Earth, nagkaroon tayo ng tinatawag class na iron catastrophe. And here in the iron catastrophe, yung iron natin napunta in the middle of the planet Earth forming your core. No, yung tatawag natin core. And yung process na yun, tinatawag yun difference. We call it as differentiation. So masasabi natin that the planet Earth itself is differentiated. So differentiated tayo kasi the planet Earth. And in planet Earth, it's arranged due to gravitational sorting, no? Kung saan lahat ng heavier or denser material natin will be in the middle, no, will be in the concentration of your center of gravity, samantalang yung mass density would be away from that center of gravity. So ganun yung case for differentiation. So dito we can expect na yung mga chondrites natin, kasi may chondrules kasi hindi pa differentiated yung parent material. Samantalang here in a chondrite, differentiated na kaya homogeneous na yung material. Ayan, no, tingnan nyo. If you're going to look at this, no, ito, this is an example of chondrite. Kaya ganyan itsura niya kasi meaning yung parent material niya, yung parent asteroid niya, or kung saan man nanggaling to, no, yung parent asteroid niya, or parent comet niya, actually not comet, let us say asteroid na lang for best exemplification, no? Yung parent asteroid nito, hindi pa siya differentiated, no? Hindi pa nakasort out yung material niya, and that is why may mga mineral grains or may mga chondrules kayo. Samantalang dito sa achondrites, no, kaya ganyan yung itsura niya, meaning well differentiated na yung parent material, and part lang to na this is just a part of the parent material. So dito, kung in the case of stony meteorite na achondrite, nanggaling siya sa rocky part ng differentiated parent material. To let you understand that, let me show you here two examples. So dito, meron tayong asteroid na hindi siya differentiated. Dahil hindi siya differentiated, tignan nyo, if you would observe, there are mineral grains present in the asteroid. Now, in this case, meron tayong differentiated asteroid kung saan yung mga heavier material, it's found in the middle, no? In the middle. So nangyayari kung dito manggagaling yung inyong meteoroid, no, sa undifferentiated parent material, we can expect we will get chondrites, di ba? We are going to get chondrites. Pero in the naman na differentiated, no, yung material natin, and nagkaroon, let us say, break off, no, off yung material. So pwedeng manggaling dito sa outer layer lang, no, sa outer layer lang yung ating rocks. At pag sa outer layer lang nang galing yung meteoroid natin, not rock, sorry for that. Pag sa outer layer lang nang galing yung meteoroid natin that this is stony meteorite na achondrite. So it's achondrite kasi gawa lang siya sa rocks, no, wala tayong mineral grains, and yun nga, aside from that, no, stony siya kasi it's taken from the outer layer which are comprised of rock. Pero if this is taken from the middle of the differentiated asteroid, what can we expect? Gawa ba siya sa rock or gawa sa metal? So what do you expect, anyone? Grade 12? Diba sabi ko, kunyari, dito na stripped of yung material sa outer layer, we would expect a stony meteoroid, no? We will expect a stony meteoroid form of aconites, no? Paano naman kung dito sa middle ng differentiated as we expect? Is it a stony or a metallic asteroid? Can someone answer my question? What do we expect? What do you think, Maureen? Mau. Maureen. Wala si Maureen.
Okay.
Middle tayo ng stony asteroid nag-break off, no, ng material. What do we expect? Is it a stony meteorite or a metallic meteorite? Mau.
Balik.
Can help. Metallic, of course, di ba? Para lang yung planet Earth, isipin nyo, nanggaling yung material sa core ng planet Earth. So we will expect a metallic meteorite. No? Meron din time na hindi siya totally sa center nakuha. So sometimes may mixture, no, ng metal and ng rocks, no. Sa meteorite natin, yung na-strip off na material has a combination of metal, no, metal and rock. So technically dito na strip off, no. And in case this would have you collect your stony iron meteorite. Tatawag natin stony iron meteorite. So anyways, no, tandaan nyo to, sa stony meteorite, it can be in the chondrites, no, in the form of chondrites, is coming from an undifferentiated parent rock, or pwede siya maging a chondrite, which means nanggaling siya sa differentiated parent. Now, tulad rin ng sabi ko, pwede rin makuha yung meteorite from the middle of the parent material, lalo na kung differentiated. So if you have a differentiated parent material at doon na strip off yung meteoroid natin, so it will be in the form of what we call as iron meteorite. Ulitin ko, it will be in the form of iron meteorite. So usually, no, yung iron meteorite natin gawa siya sa dalawang metal. It's made from iron and nickel. So iron is and the nickel is in the form of taenite, no? Again, usually yung mga iron meteorite natin or yung mga metallic meteorite, it's made from iron and nickel. So ang iron component is natawag na kamacite, samantalang yung nickel component tinatawag na taesite. So, and sometimes may impurities rin siya in the form of graphite and trolite. So these are actually impurities of your metal or your iron meteorites. So yung classification niya, it would depend on the percentage nickel present in your meteorite. So pag 46% nickel, it's called as hexahedrites, no? Pag 62% yung nickel, this will be called as octahedrites, and pag greater than 12% yung nickel composition natin siyang ataxite. So tatandaan niyo yan. Nakaklasify yung iron meteorite based on the percentage nickel. No? Sometimes sa mga metallic or sa mga iron meteorite natin, makakakita kayo ng ganitong pattern. We call this as the Widman-Staten pattern. So bakit tayo may Widman-Staten pattern? Remember, di ba, na yung mga natin, meteorites natin, when it enter the planet Earth, nag-vaporize siya. So technically, nag-melt siya for a while, and pag impact, it would cool rapidly once it reached the surface of the Earth. Now, pag nag-cool siya, nga mabilis yung cooling process natin, nakaka-form tayo ng ganitong pattern. And tinatawag natin itong pattern na to as a Widman-Staten pattern. So this Widman-Staten pattern is the pattern that resulted from the rapid cooling of your metallic or your iron meteorite once it hit or once it reached the surface of the planet. And class, ito, these are other examples of iron meteorite. And makaklasify natin to based on nickel concentration or the percentage nickel present in your meteorite. At yun nga, yung meron tayong tatag na stony iron meteorite. And kung stony iron meteorite, ito yung mga meteorite na merong metallic part and rock part, no? So, meaning na strip off siya galing from the metallic and rocky part of the differentiated asteroid. So, it can be the form of pallasite and mesoiderites, no? Pag pallasite, usually, ito, may olivine kayo, yung olivine crystals na nakasurround doon sa inyong iron-nickel matrix. Ayan. Ito yung olivine crystals nyo. Itong olivine crystals nakasurround sa kanya yung iron-nickel matrix. So, we call that as pallasite. Ayan, these are pallasites. These are olivine crystals, no? These are crystals surrounded by iron-nickel matrix. Ito naman, this is an example of mesoisederites, no? Ayun, mesoisederites. So dito, sa mesoisedierite, meron siyang plagioclase and pyroxene, no, surrounded by the iron-nickel matrix. These are plagioclase and pyroclase and pyroxene minerals surrounded by iron-nickel matrix. Now, sir, bakit mukha siyang chondrites? Why does it look like chondrites? Okay, actually, nagmukha siyang chondrites because, di ba, nung nag-enter siya sa planet Earth, nag-melt yung meteorite natin. So, remember, pag nag-melt yung meteorite, at dahil gawa siya sa both rocky and metallic material, yung metallic material, walang problema eh. The metallic material will keep its integrity. But the rocky material, pag nag-melt siya, magbe-break down siya into its mineral component. And that is why dito nangyari pag nag-dry off siya, na-incorporate yung mga mineral coming from the rocky portion, no? Rocky portion of the meteorite na i-inculcate siya, no, or na-incorporate siya doon sa iron nickel matrix ng ating stony iron meteorite. Once na nag-cool down yung stony iron meteorite natin when it hits the surface. And anyways, itong tatlong to, these are the three kinds of no, are the three kinds of meteorite that we can collect as faults and finds, no. Yan yung tatlong klase ng meteorites natin that we can collect as false finds. And do not worry, meron kayong activity in the module where you are going to classify different meteorites based on its characteristic. Meron rin ako in-upload doon na meteorite identification sheet that would help you identify the different kinds of meteorite. So, before we proceed, do you have questions?